Hello, Algebra 3 students. This is Mrs. Norton, and the first thing we're going to be talking about in Chapter 1, well, all of Chapter 1 is about the basic concepts that you encounter in algebra. So here's the lineup. The first section is about just study skills, and we're actually going to skip that. And then what this lesson, what I have for you today, is going to be on Section 1.2. And we're going to be talking about sets and other basic concepts. And then Section 3 is going to be about properties of operations with real numbers. And then 4, order of operations, 5, exponents, and then 6, scientific notation. So all of these are concepts that we have gone over somewhere in our algebra career in the past, probably way back in the past for many of you. So sets and other concepts. All right, so we have, there's a lot of number sets, and here are some of those. Natural numbers are like, they're also called counting numbers, like 1, 2, 3. That's how you always start out counting. So start with 1, 2, 3, and then keep on going up. And then whole numbers, the only difference between whole numbers and natural numbers is that it has added the 0 to it, and then it goes on up. Integers, stemming from whole numbers, we now have all the negative values, okay? And then rational numbers, the set of all numbers that can be expressed as a quotient, a fraction, okay? And even including all of these up here, these can be represented as fractions too. Everything can be divided by or put over the number 1. So all of the numbers mentioned above are rational, and now the rational set of numbers includes fractions too, like 1/2, 1/3, 3/2, and things like that. And then all of these right here are real numbers. The set of all numbers that can be represented on a number line. So even including things like pi and the number e and things like that. Here you go. Here's a nice little chart that can also help you in remembering what is what. So we have real numbers up here, and it splits into rational numbers and irrational numbers. Now, irrational numbers are numbers that cannot be expressed as a fraction. So remember, rational numbers are numbers that are expressed as fractions. Irrational are those numbers like what I just mentioned on the previous slide, like pi. We cannot represent that as a fraction. There is no fraction out there. Same goes with the value of e. That is irrational. And also another irrational number, any square root of a number like 2 or 3, something that you cannot take the square root completely, like a number that can be that is a complete square is like 4 or 9 or 16, 25. All of those numbers you can take the square root of, so those become, this set of rational numbers. But also square root of 2, just telling you, that is irrational. And then off of rational numbers, we have integers and non-integer rational numbers. And then let's see, integers split up into negative integers and whole numbers. Remember, whole numbers include 0, and then natural numbers does not. Okay, set builder notation. First, we're going to look at what is roster form. Roster form is just a set of numbers listed out in this type of curly braces right here. But if a set of numbers cannot be listed in roster form, we use something called set builder notation, and I'm going to show you what that looks like on the next slide, and then I have a few examples too. So here is set builder notation and what everything about it represents. So like I said, these curly braces we're going to use as putting everything inside the set that represents a set of numbers. So this set, and then x is our value, our variable. So the set of all elements x or y or z, depending on what variable you want to use. And then this line means such that. So all elements x such that, and then we list the property of x. And we'll get into that in our example, but here's one down here. So we're going to call this set E is equal to the set of all elements x such that x is a natural number greater than 1. There are other ways that we're going to represent this sentence right here that is given x is a natural number greater than 1. And again, like I said, you're going to see that in the next example. Here is this set E in roster form, so a list of numbers in this set of brackets. So E is equal to anything, let's see, all natural numbers greater than 1. Actually, it should say greater than or equal to. So let's say we're going to omit that 1. That's not supposed to be there. So every number greater than 1 that is a natural number is 2, 3, 4, 5, and so on. That's why you see the little dot, dot, dot. Then on a number line, if you were to represent this set on a number line, again, let's exclude that number 1 that's there. You would just, natural numbers are no fractions here, so we're just going to put a dot at each number here that this set is representing. So 1, 2, 3, 4, 5, and so on. Okay, so example 1, I'm going to give you a set and we're going to list it in roster form. So here's the set I'm going to give you. I'm going to say A is equal to set of all elements x such that -1 is less than x is less than 1. And x, all right, what this means over here, x, this means is in the set of natural numbers. That's how you write natural numbers, and what this means is in or inside, okay? So let's write this in roster form. And can you think of any number that is between, that's what this up here means, it's between -1 and 1 that is in the set of natural numbers? Well, the only number that is natural numbers and is between -1 and 1 is 0. So that's what we're going to list. A is equal to 0. That is roster form. Let's look at one other example here on listing numbers out in roster form. I'm going to say E is equal to all elements x such that x is less than 3 and x is in the set of whole numbers. Okay, so all numbers greater than 3, that is a whole number, we're going to list it out like this. So the first number that is greater than 3 is 4. Or sorry, less than 3. a number that's less than 3, it would be 2. And then you would keep on going down. So 1, 0, then that's it. Because whole numbers do not include negative values. So here we go, 0, 1, 2. And there we have it, our set expressed in roster form. In our next example, we're going to be asked to find the union and intersection of set A and B, and I'm going to list those sets out in just a second. But what symbol we use for union, it looks like this. Oops, sorry, pen tool here. Union, and then intersection is that symbol. And kind of to visualize what symbol goes with what word here, we can look at the union symbol. Well, it's a U, so U for union. Intersection, another word for intersection in logic is the word and. In union, we use the word or. But intersection, if we use the word and is another way to state it, you can say this one kind of looks like the capital A. So capital U, capital A, if we cross the line across. Anyway, let's look at an example. So I'm going to list 2 sets. I'm going to call A is this set of numbers. Let's see, let me find my numbers here. -3. And then B, the set B is this. So to find the union, let's do the union first, of A and B, it is stated like this. A union B. What it is, it's another set. We're going to combine these sets. And we're going to just say, we're going to list the set of numbers in these put together. Because what is in one set or another set is everything. So list everything that is in both the sets without repeating it. So -3, -1, 1, and 3, it comes from A. And then also list out B without repeating the ones that you already did. So -4 and -3 is already there. -2, -1 we already have, and then 0. And there we have it, A union B. Now let's do the intersection. So the intersection of A and B is going to be all the things, all the values inside these 2 sets that are in common. That is what's going to be listed in A union B. Because we're looking for the values that are in both A and B. So the values that are in both A and B, well, let's look at this. Do I have a -3 in B? Yes, I do, so list it. What about the -1? Yes, I do. List it. Anything else? Let's see. The 1, no, that is not in B. 3, no, that is not in B. So that's a good way to go through and find what numbers are in common. Just go through one list and find if it's in common with the other one. And that is done. -3 and -1 makes up the set A intersection B. Any more examples that you want to see on the unions and intersections, let me know in class. We're going to move on. All right, on this example, it says illustrate each set on a number line. So I've already shown you a little bit on how to read the set builder notation. It says, this first one says x such that x is greater than or equal to 0. So on a number line is what we're going to represent. So I'm going to write my number line. So all the values greater than or equal to 0. I'm just going to start with 0 because everything's greater than that number. And so on. So since it's greater than or equal to, we're going to put a dot here, a filled in circle. If it's just less than, just like down here in this example, if it's less than, what we're going to do, instead of a dot, we're going to draw a circle on that part of the number line. So it starts at 0, and I'm going to draw it in a different color. Starts at 0, and then goes that direction. And that's it. That's illustrating this set on a number line. Let's do the next one. So it states all values of x such that x is less than or equal to 2. So let's draw some numbers on a number line. I'm going to start over here. I'm going to say 2, 1, count backwards, 0, -1, -2, 3. All right, there is a number line. Now let's represent this set on it. So we're going to start at the number 2, and remember it gets a filled in circle, and it's going to go this direction because that set is all the values less than or equal to 2. Now on this last one, x is in between two numbers. So this is how I'm going to read this last set. So x such that x is between -6 and 3. You can state it as -6 less than or equal to x less than 3. But whenever you have an x between two numbers in an inequality like this, it's just between -6 and 3, or the two numbers that is stated. Let's write that. I'm going to start at -6 and then go up to at least -3. -2, -1, 0. 1, 2, 3. All right, so all the numbers that are between -6 and 3, this is how we're going to represent it. Because this right here is a less than symbol, on that number it gets a filled in circle. So make sure you fill it in. And then down at the end where you see 3, because of this symbol right here, it's going to get that open circle. Like that. Now, just draw your line representing all the numbers between those two values stated. And that's it. That's representing these sets on a number line. Last example. All right, sorry, at the top here, it's supposed to say this is example. Whoops. Example. Number 4. And we're asked to express in set builder notation each set of numbers that are indicated on the number line. Well, let me give you a number line. Oh, sorry, going the opposite direction. Okay, so I'm going to say, let's start this number line out at 1, with a filled in circle, and it goes to the right. So we're going to express this in set builder notation. We need our curly braces there, and the X, and then the such that, and then all of these values are greater than or equal to, because of this filled in circle here. So greater than or equal to 1. So X is greater than or equal to 1. And there you go. That is set builder notation for this number line. I'm going to show you one more example within this. I'm going to draw another number line. Let's do this. -2. Okay. And if I start at this number 2 with an open circle, and then I draw my line up to number 3 and do a filled in circle, let's do that in set builder notation. So like I said, open circle means it's just a less than symbol or a greater than symbol, no equal to. So X such that. Now it's between two numbers, so I'm going to say let's put X between two numbers. And what we're going to start with is, because of that open circle, is just a less than symbol. And then we're going to end, because of the open circle on 3, or sorry, the filled in circle, end with a less than or equal to symbol. Now write your numbers, -2 and 3, and we're done. So that is all I have for you in this lesson today. I hope you got some out of it, and I will see you in class. Goodbye.